This is another video on derivation for the proving the reduction formulas for the cos to the n, any power of cos. My previous video on this reduction formulas on secant and tangent. So proving this, we write the integral of cos to the n of x dx split into as cos to the n minus 1 of x multiplied by cos of x dx. From here, we'll use our formula of integration by parts. So the formula of integration by parts is the integral of u multiplied by dv of dx equals to u multiplied by v minus the integral of v multiplied by du. So we'll have to choose, from here we'll have to choose our u and our dv. So it's the correct method of choose, we use a formula, let. So these are logarithmic functions, inverse trigonometry, algebraic functions, trigonometric functions, exponential functions. So our correct value of u, my choice of u, follows this order. So from our integral, we have two functions that are being multiplied. This is inverse trigonometry I. So this is trigonometry. So from our formula, inverse trigonometry starts, trigonometry follows. So automatically this will be our u. So our u will be that. Computing those, we'll get our u as cos the n minus 1 of x. Okay. So our du, our dv, it's everything inside the integral. Our dv equals to cos of x dx. From our formula, we have our u, it's here, our dv, it's here, our u, it's here, our v, we calculate it from here. So this is the derivative of v. For you to get v, you'll have to do the integral of cos of x dx. You'll get it as sine of x. In our formula, we have du. So we have to find our du. So our du's will be gotten from, this is our u. So we'll be differentiating u with respect to x. So we'll get our du as taking the power, the general power rule, multiplying it in front, you get n minus 1 multiplied by the function itself. Cos. It's cos. It's cos multiplied by cos multiplied by cos to the n. And now we usually subtract 1 from the power. So it is n minus 1 minus 1. It will be n minus 2 of x multiplied by the derivative of the inside. The inside function is cos of x multiplied by cos of x. This is general, this is chain rule. It will be multiplied by negative sine of x, and it's with respect to x, so it will be dx. Substituting into our formula, we'll get the integral of this cos to the n minus 1 of x multiplied by cos to the x dx is the same as our u. Our u is cos to the n minus 1 of x multiplied by our v. Our v is sine of x minus the integral of our v sine of x multiplied our du. Du will be n minus 1 multiplied by cos the n minus 2 of x multiplied by negative sine of x dx. Okay, so these are constant. Take it outside the integral. This is sine of x multiplied by sine of x. It will be sine squared of x. So let's substitute. It will be the integral of cos the n minus 1 of x multiplied by cos to the x dx equals to cos to the n minus 1 of x multiplied by sine of x minus the integral of sine squared of x, okay, multiplied by n minus, we said these are constant term inside the integral. We get it outside. So get it outside the integral, it will be minus n minus 1, but it will be now like close the bracket and open it to all the remaining functions. So it will be now inside of sine multiplied by sine, it's sine squared. So to sine squared of x, it has negative, so it will be negative sine squared of x multiplied by cos to the n minus 2 of x. From here, having known the Pythagorean identity for sine, we usually say cos squared of x plus sine squared of x is the same as 1. So we'll have to replace sine squared of x. So sine squared of x, taking cos squared to the right side, we'll get sine squared of x as 1 minus cos squared of x. Substituting that to this, we'll get the integral of cos the n minus 1 of x multiplied by cos x dx equals to cos the n minus 1 of x multiplied by sine of x minus n minus 1 inside the whole, open the whole bracket. So this we replace with 1 minus cos squared to the x. So these are negative sign. Cos, it will be 1 minus cos squared, 1 minus cos squared of x. Again, that multiplied by that cos to the n minus 2 of x, close the bracket. From here, let's distribute this inside the integral. Again, let's open this. So we get our integral of cos to the n minus 1 of x multiplied by cos to the x dx equals to cos to the n minus 1 of x multiplied by sine of x minus, let's just write minus n minus 1. Opening this bracket, we'll get negative 1. Okay, let us take this negative here. So it will be negative cos to the n minus 1 multiplied by 1. Opening the bracket, we'll get negative cos to the n minus 2 of x. So multiplying this with this, it will be positive. So it will be plus it will be minus, sorry. So this is negative, it will be minus, it will be positive, it will be positive. Negative multiplied by negative, it's a positive, so it will be cos squared of x multiplied by cos to the n minus 2 of x, close the bracket. So let's write, and let me rub. So we'll have the integral of that. So let's open the bracket. Let's open the bracket using this. So we'll get the integral of cos raised to n minus 1 of x multiplied by cos of x dx equals to cos n minus 1 of x multiplied by sine of x. Distributing these inside, you get negative n minus 1 multiplied by this. Okay, sorry, I failed to place an integral sign. There's an integral sign here, then the bracket. So there's an integral sign, we didn't indicate. So multiplying these, opening up the bracket, we'll get this multiplied by this, it will be positive, negative, but it will be positive, so it will be plus n minus 1, so it will be plus n minus 1, the integral of these cos the n minus 2 of x, multiplying these again with this negative sign, changes this to be negative, so it will be minus n, so it will be minus n, the integral of this. So we will be we have already split these into two integrals, so we'll get n minus n plus n, plus n, open the multiply by the integral of the n minus 2, cos the n minus 2 minus n minus 1, multiplied by the integral of this cos squared of x multiplied by cos to the n minus 2 of x to the n minus 2 of x dx. So from here we'll get, so from here cos squared to the x multiplied by cos squared to the n minus 2, adding the powers, you get n minus 2 plus 2 is just the same as cos to the n of x. From here again, adding the powers, it will be n, so there's raised to 1 here. So it will be n minus 1 plus 1 is just n. So from that, we get this expression is the same as this expression. So taking it to the left side and adding the coefficients, we get, so we'll take this expression to the right side, then we add the coefficients. Adding the coefficient for this is 1. So it will be, as adding the coefficients, we get, taking this negative of n minus 1, taking it to the left side, it will be positive of n minus 1. So we'll get n minus 1 plus this, plus 1 is the same as n. So we'll take this to the right hand side and adding the coefficient. So we'll get the coefficient as n, the integral of cos the n minus 1 of x multiplied by cos of x dx equals to cos n minus 1 of x multiplied by sine of x plus n minus 1, the integral of cos to the n minus 2 of x. We want the integral of cos, to the n power dx. So this is just this. We want this also, we'll have to divide by n. Divide this by n. Again, divide this by n. So our final expression will be n goes with n, so it will be the integral of cos to the n minus 1 of x multiplied by cos to the x dx equals to 1 over n cos to the n minus 1 of x multiplied by sine of x plus n minus 1 over n, the integral of cos to the n minus 2 of x. So we have already proven this is the answer. So equating into I is the answer, plus a constant c. So having this formula, you can integrate any power over cosine. For example, given cos to the 9 or 10 of x, told to integrate, it will be easy. So just replace 9 here, replace 9, yeah. So this is the reduction formula. This is the reduction formula for cosine. This is how we prove it. This is the answer. This is the formula for the reduction formula for cos to the any power of x. My next video will be tackling proving the reduction formula for sine. My previous videos we tackled secant to the n, tangent to the any power. This is the cos to any power. The final video will be looking on sine to any power. Don't forget to like and subscribe. Thank you.